Hello everyone, welcome back to my YouTube channel. This is Manasa. I'm from third semester from the Department of Electronics and Communication. Today I came with a new topic, superposition theorem and its example of problem. So first one, superposition theorem. So statement, it states that in any linear bilateral multi-source network, the response in any branch it is equal to algebraic sum of the responses obtained by considering each source acting separately by making all other sources set equal to 0. So this is the statement of superposition theorem. Next is proof let us know. So here consider the network as shown. Here there are two loops, that is I1 and I2. So I1 is flowing from, in loop 1 I1 is flowing from negative to positive, but if we come to on loop 2 I2 is flowing from this was negative to positive. So there are Z1, Z2, Z3. So for this, let us apply KVL for loop 1. If we apply KVL for loop 1, then Z1 I1 plus Z2 I1 minus I2 is equals to V. So Z1 plus Z2, let us take I1 minus I2 Z2 is equals to V, but we know that I2 is equals to I, so Z1 plus Z2 I1 is equals to V1 plus IZ2, so I1 is equals to V plus IZ2 by Z1 plus Z2. So let us call this as equation 1. So we know that I2 is equals to I from loop 2. So Ix is equals to I1 minus I2. So V plus IZ2 minus I divided by Z1 plus Z2. So V plus Z2 I minus Z1 I minus Z2 I divided by Z1 plus Z2. So let us call this is equation 2, that is V minus Z1 I by Z1 plus Z2 is equals to Ix. Let us call this as Ix. So let us come to verification of equation 2 by superposition theorem. So to apply superposition theorem, so consider one source at a time. So in case 1, consider voltage source and set current source to 0. For example, open circuit it. So in case 1, consider voltage source and set all the current to a 0. So in this diagram we can see that we should consider that first we should, in case 1 we should consider voltage source and set all the current source to a 0. Then equation will be I1 is equals to V by Z1 plus Z2. Here in circuit we can see that there is only one loop. So in case 2, consider current source and source voltage source 0. For example, short circuit it. But in case 2, we should make current source as short circuit. So if that is a condition, so the equation will be I2 is equals to Z1 by Z1 plus Z2 by minus I. So according to superposition theorem, actual current Ix is equals to I1 plus I2. After finding the value of I1 and I2, and so then after that we are going to find Ix. So V by Z plus Z2 minus Z1 I by Z1 plus Z2. Ix is equals to V minus Z1 I by Z1 plus Z2. So this is equation 3. So we can see that equation 3 and equation 2 are same. So and superposition theorem is proved. Let us go to a problem that find current through 2 ohm resistor connected between terminals A and B using superposition principle. So we can see that there is a there is the diagram where there are 3 loops, that is I1, I2, I3. In I1 we can see that there is 2 and 2 ohm, and if we come to I2 there are 12 ohm, 1 ohm and 2 ohm, and if we come to I3 there are 2 ohm, 3 ohm, 4 ohm. So for this, so first let us apply KVL to loop 1. So here we can see that apply KVL at loop 1. If I apply this KVL to this first loop, then it will be current is flowing from negative to positive. So minus 2 plus, because voltage source is there, so minus 2 plus 2I1 plus 12 I1 minus I2, because we are considering first loop, so we should consider first I1 and then I2, because current I1 and I2 are flowing in same direction here, is equals to 0. So minus 2 plus 2I1 plus 12 I1 minus 12 I2 is equals to 0. Then the equation will be 14 I1 minus 12 I2 is equals to 2. So this is equation 1. So let us apply KVL at loop 2. If we apply KVL at loop here, so there is 12 I2 minus I1. Why? Because here we are considering first as loop 2. So we should take I2 minus I1. 12 I2 minus I1 plus 1 I2 plus 2 I2 minus I3 is equals to 0. Then the equation will be 12 I2 minus 12 I1 plus 1 I2 plus 2 I2 minus 2 I3 is equals to 0. So then the equation will be minus 12 I1 plus 15 I2 minus 2 I3 is equals to 0. So this is equation 2. So if we come to here loop 3, apply KVL to loop 3, that is 2 I3 minus I2, because I3 is flowing from here and I2 current is coming from here. So 2 I3 minus I2 plus 3 I3 plus 4. Here the current is flowing from positive direction, so plus 4 is equals to 0. Then 2I3 minus 2I2 plus 3I3 is equals to minus 4, because if voltage source come this side, so it will be minus 4. Then the equation will be 5I3 minus 2I2 is equals to minus 4. Then this is we call equation 3. So here if we done matrix multiplication, then I1 will be 0.167, I2 will be 0.029, I3 will be minus 0.78, because here we are finding the I1, I2, I3, that is current. So Ix will be I2 minus I3, because in question they ask you to find the current through 2 ohm. Current through 2 ohm, that is 2 ohm is here. So I2 minus I3, because this 2 ohm resistor will go for I2 and also I3. So I2 minus I3, that is I2 is, what is the value of I2 is 0.029 minus I3 is minus 0.78, that is Ix will be 0.809. So in case 1, consider 2 volt and short circuit the 4 volt. So if we come to in case 1, let us consider this 2 volt and let us short circuit this 4 volt. So then there will be 3 loops. So let us apply KVL at loop 1. If we apply KVL at loop 1, then minus 2 plus 2i1 plus 12i1 minus i2 is equals to 0, that is 14i1 minus 12i2 is equals to 2. This is equation 1. Then if we apply KVL at loop 2, that is 12i2 minus i1 plus i1 i2 plus 2i2 minus i3 is equals to 0. That is, the equation will be minus 12i1 plus 15i2 minus 2i3 is equals to 0. So this is equation 2. So let us apply KVL at this loop 3. If we apply KVL to loop 3, then the equation will be 2i3 minus i2 plus 3i3 is equals to 0, because here there is nothing current is there or a value is there. So 2i3 minus 2i2 plus 3i3 is equals to 0. Then the equation will be 5i3 minus 2i2 is equals to 0. Let us call it as equation 3. After matrix multiplication, I1 is equals to 0.51, I2 is equals to 0.43, I3 is equals to 0.17. So after finding case 1, let us find I1. I1 is equals to I2 minus I dash is equals to I2 minus I3. I dash will be 0, I2 is 0.43 minus I3 is 0.17, that is I dash is equals to 0.26 amps. So if we apply in case 2, let us consider 4 volt. So let us consider this 4 volt and let us short circuit this 2 volt. So if that is the condition, then let us apply KVL at loop 1. If we apply KVL at loop 1, that is 0 plus 2i1 plus 12i1 minus i2 is equals to 0. Then the equation will be 2i1 plus 12i1 minus 12i2 is equals to 0. It is 14i1 minus 12i2 is equals to 0 is equation 1. So let us apply KVL at loop 2. If we apply KVL at loop 2, that is 12i2 minus i1 plus 1i2 plus 2i2 minus i3 is equals to 0, that is 12i2 minus 12i1 plus 1i2 plus 2i2 minus 2i3 is equals to 0. Then the equation will be 15i2 minus 12i1 minus 2i3 is equals to 0, that is equation 2. So if we apply the KVL at loop 3, that will be 2i3 minus i2 plus 3i3 and plus 4 is equals to 0. 2i3 minus 2i2 plus 3i3 is equals to minus 4. Then the equation will be 5i3 minus 2i2 is equals to minus 4. Then this is equation 3. So after matrix multiplication, I1 will be minus 0.35, will be minus 0.40, and I3 will be minus 0.96. So I double dash will be I2 minus I3, I2 minus I3, that is I2 will be minus 0.40 and I3 will be minus 0.96, that will be double dash will be 0.56 amp. So this is a case 2 condition. So by superposition theorem principle, Ix is equals to, equation of Ix will be I1 plus I1 plus I2. That is, after finding I1 and I2, we can find Ix. Because to find Ix we need I1 and I2. So I1 is 0.26 plus I2 is 0.56. So Ix will be 0.82 ampere. So thank you for watching my video.